Alright guys, welcome back to the channel. Today we're going to be going over a basic understanding of tropospheric ducting, sporadic E, and meteor scatter. So, what is tropospheric propagation? Well, you can kind of see over on the left side of the screen there, a nice little diagram. Goes up, comes back down, can do some hops and get you a little bit further out than what you would normally get with VHF. So it usually refers to the electromagnetic propagation in relation to the troposphere. So normally the higher up you go in the atmosphere, the colder temperature gets. Under high pressure conditions, it can cause the temperature to invert. This is known as a temperature inversion. This will cause a layer of air in the troposphere to become warmer than the layer below it. The temperature inversion essentially creates a duct for the signals that travel on. Normally VHF, UHF are line of sight, but under the right conditions, this temperature inversion, you can transmit a lot further than you normally would. What would normally be a weak signal, you can receive it much, much stronger. Over here on this side, you can see on the right side where the troposphere is at. Starts at the ground and goes up to 10 kilometers. So this ducting or propagation can happen just about any time, but it's more prevalent during the summertime months. Usually when the days are hot and the nights are cool. That's when you can get that temperature inversion going on. It's real common on the coast. I'll provide a link to a website. Actually, you can see it there on the third bullet point, where you can actually look on this map, and on the overlays you can kind of see where the propagation is happening. When tropospheric ducting is happening, it can be hard to tell how long it'll last. It's usually very short. It can last several hours, it can last longer, it could be minutes. It's just kind of hard to tell with it. There's the website, aprsmentalink.org. And tropospheric ducting, it's a great way to make long-distance contacts when the conditions are good. Like I said, normally you can get out a lot further. I've done several hundred miles on VHF when there was some good ducting going on. So we'll move into sporadic E. As the name suggests, it is sporadic. It bounces off smaller clouds or unusually ionized atmospheric gases in the lower E region. And over on the right side, you can kind of see the ionosphere layers. You can see the E layer is up there at 120 kilometers. It's useful for long-distance communications. It can cause some interference with commercial radios, just because some of them are within that 155 megahertz range. It's used by hams on 10.6.2 and 1.25 meters, but you'll see it most commonly in the lower VHF bands. Sporadic E is an abnormal event, but it can happen at almost any time. It does have some seasonal patterns, but it can happen just about any time. Predictably, in the summertime it peaks in both hemispheres. Signals received via sporadic E can be very strong for a short period of time. Polarization shifts can occur on the longer hops, but on the shorter hops it tends to remain in the original polarization. So sporadic E offers many possibility ham radio operators. You can use sporadic E to send CW or any of the digital modes, voice. There's just so much you can do with it. Happens as high as 2 meters, and like I said earlier, it's generally very short-lived. At the polar latitudes, sporadic E can accompany auroras or auroral propagation. On the lower bands, it is a little longer lived and they're a little more frequent during the sunspot minimums. So meteor scatter. Meteor scatter is a lot of fun. Meteor scatter, also called meteor burst communications or meteor scatter communications, is propagation that exploits the ionized trail of meteor during entry of the atmosphere. So when the meteor comes in, starts burning up, there'll be ionized particles in that trail that do become, I guess, the pathway for the signals to travel on. So conditions when a meteor enters the atmosphere and begins to burn up creates a trail of particles in the E layer. The ionized trails can be very dense. Radio waves can be reflected. The radio waves that can be reflected are determined by the intensity of the ionization, and it generally affects the 30 to 50 megahertz range, so 6 meters. Again, you can use meteor scatter communications with JT9, MSK144, FT8, voice communications, pretty much anything like that. So the military actually did use a little bit of meteor scatter. Old system called communication by meteor trails, or COMET. It was used by NATO for long-distance communications. COMET became in operation in 1965, but faded out for satellite communications. There was another one called Advanced Meteor Burst Communication System. Once again, for the ham radio. We use it on 6 meters generally. That's the band it usually affects. Communication can be made between two stations from a long distance. Very short-lived, of course. MSK144 and Morse code can be used. So if you get the time to try meteor scatter, I highly suggest doing it. Try it during a meteor shower and see if you can't make any communications out there. But I think that is pretty much it. There's my sources, and that's the end. So I hope you guys kind of learned something today. Once again, this is just a very basic understanding, my understanding of how this stuff kind of works. I wanted this to be kind of just an entry-level, very basic, hey, I just got into ham radio, I don't quite understand these kind of things, kind of teaching material, I guess. So yeah, let me know how I did. This is my first time trying it like this, so leave a comment, or I guess feel free to share it. Till next time, thanks guys.